So here I will solve a problem on instantaneous center of zero velocity. We have a cylinder that rolls without slipping. That's very important. So it's between two moving plates. That upper one moves with a velocity of 0.25 meters per second, and then lower one moves with velocity of 0.4 meters per second. The radius of the cylinder is 0.125 meters. The question is that what is the angular velocity of the cylinder and what is the speed or the velocity of the center VC? That's the question. Okay, so let's remember that for the wheel there is a point that it has a zero velocity, and the other points are like that they are rotating around this zero velocity. This center. Similarly here, we will look for what is the center such that A and then B rotates around that center. That B will take the velocity of the D because there is no slip. So that will be 0.4. And then A will take the velocity of E, which is 0.25 meters per second. Okay, and because again there is no slip. So if I do that way, so this one will be the point A, and then that one will be the point B, and then it will be to the left. Okay, this one is 0.25 meters per second, and this one is 0.4 meters per second. And then we will assume that A and then B, assume A and then B rotate about an imaginary axis, okay, or center, which we call as the instantaneous center, okay, IC. And then the question is that how do we find the location of IC? How we can find the location of IC? So what we can do is that, so I will say that then A is like it rotates about this way, about some circle, yes. And then I know that for a circle, the tangential velocity is perpendicular to, so tangential velocity is perpendicular to radius. Okay. And therefore I imagine that there is a center for this circle, so I can say that the center is somewhere around here. Okay, and then this one is 90 degrees. Similarly for point B, and this one also rotates around some circle. Okay, and this circle will have also some instantaneous center of, okay, IC. So let me first do it here. This is for B, and then this is for A, and this is for B. Okay, but this doesn't simplify the problem. So this method of 2IC, it doesn't simplify the problem. Because now I have 2IC, so we introduced two unknowns, okay, which is IC of A and then IC of B. What is the better one? The better one is so to find a center such that A and then B rotates about it. So we can find a center such that A and then B rotates about it. So to find that center, I will just draw it here one more time. So I will say that this is the A and then I have the B. Okay, and then I will say that there is a center for both of it. Okay, so this center may be here, it may be here, whatever, yes. There is a center for both of it so that they both rotate around this. They both rotate around this center. Okay, so the next is, I will say that the center is here. Okay, this is the instantaneous center. And then I can draw it from here to that and passing through this instantaneous center. Okay. If you remember, this is very similar to method here that we talked about. Then the problem becomes a little bit easier now because I have a common center for A and then for B. Okay, this additional line, is to make solution easier. So you will see how it makes easier. So the first thing is that the velocity of A is equal to the velocity with respect to instantaneous center plus then omega, let me write in a scalar form, omega into the RA with respect to instantaneous center. And then I know that this one is 0, and then velocity of A, I know that that is 0.25. The similarly velocity of B will be equal to then omega into RBIC, and this one is 0.4. Okay. Now from here what I can do is that I can say that 0.25 by 0.4 will be equal to RAIC by RBIC. Okay. This is the one equation. One equation, two unknowns. I need one more equation. One more equation says that this is the RBIC and this one is RAIC. The additional equation will come from that the sum of these two is the diameter, which is 0.250. So RA with respect to IC, RB with respect to IC is 0.25. Okay, this is the second equation. And then I can write this A in terms of B and then replace it here. So that will be 0.25 by 0.4 times RBIC plus then RBIC, that will be 0.25. The first term makes 0.63 RBIC plus RBIC is 0.25. From here I can find that 0.25 by 1.63 makes 0.153. So RBIC becomes 0.153. Okay. Similarly, you can find the, just by replace, you can find RAIC. That will be that this one, which is 0.63 times the value here. So 0.63 times 0.153, 0.096. Okay, Finally, the omega you can find either from the first equation or from the second equation. If you just replace it, so then omega will be 0.25 divided by RAIC, which is 0.096, and that will be equal to 0.25 by 0.096, 2.60 radians per second. Okay, that is the first part of the question.